Okay, so let's have a short orientation about General Physics 2. So this will be your second semester, your last semester here in Shanghai, guys. So this will be quarter 1. So again, ako na po muna ang magiging teacher nyo uli sa General Physics 2. So let's know about the course description of General Physics 2. So we will tackle about electricity, magnetism, optics, the basic of special relativity, atomic and nuclear phenomena. Again, and different methods. So meron tayo ditong mga dapat balikan, guys. Like for example, geometry, trigonometry, graphical analysis, and basic calculus. But take note na hindi naman to almost lahat ay anuhin talaga natin, di-discuss natin yung bawat sulok niya kasi medyo kulang din yung oras natin. We only have 8 weeks, di ba? On both quarters. So, some of them, introduction lang, pero meron din naman pipilitin nating matakel yung mga let's tackle about the timelines o yung mga content na pag-aaralan po natin. So, we have 6. For content 1, we have electric charge, Coulomb's law, electric fields, and electric flux. Then also electric potential, capacitance, and dielectrics. So kung mapapansin nyo, talagang iikot yung ating discussion sa electricity and magnetic field. Current, resistance, or the Ohm's law, then electromotive force, may mga discussion din about circuits such as DC, direct current, then force due to magnetic field, and sources of magnetic field. Actually, may 7 na content yan, pero yung pang 7 will be the integration of all the contents. Ay, kasi yun naman, pabukas naman po ako ng camera ng iba kung hindi naman makakasagabal sa bilis ng data. So, kung lang kayo makita, wala 3 weeks tayong hindi nagkita-kita, guys. Okay. Na po, punta po tayo sa timeline. I believe ito naman po ay napakita na sa inyo kasi nag-send din naman talaga kami nung list of requirements para nga hindi kayo matambagan, hindi kayo mabigla. So for week 1, we're going to have worksheet 1.1, then week 2, worksheet 1.2, and then we're going to have a long quiz on week 3. And same pa rin naman po yung ating gagawin. Every week may discussion and then may iiwang worksheet sa asynchronous na to be passed for the next week. Tapos yung long quiz natin, every Friday pa rin siya, 9 to 10. Google Forms pa rin po yun. And also, magkakaroon po tayo ng graded recitation uli. Week 4 yon. Week 5, another worksheet, which is number 2. Then we're going to have a long quiz po uli. So, dalawang long quiz lang sa ating quarter 3, which is on week 6. Week 7, magkakaroon tayo ng worksheet 3. And then, obviously, week 8 will be the final assessment. Exam din po ito. Then, yes, we're going to have your last quarter after that week 8. Rules, balikan ko lang po, sana magkaroon po kayo o sa puso at sa isip niyo yung rules na to. Please participate always and communicate to me. Makikisuyo na. Kung halimbawa ay merong hindi makakapagpasa on time ng mga outputs, madali naman akong kausap, basta i-message nyo ko. Ha? Ang hirap kasi nung yung hindi ko alam kung magpapasa o hindi. Ang gusto ko lang naman ay mag-message sa akin. Para at least hindi ako nangangapa, gigradean ko na baga to o hindi. Kasi sa totoo lang, ayokong mag-grade ng merong may kulang. Kasi sino bagang gustong magbigay ng mababang grade? Gusto ko rin naman mataas kayo. So, tulungan ng sarili. Be diligent always. Gawin ng mga outputs na kaya naman na gawin agad. And then always have a respect, hindi lang po sa akin, kundi sa inyo mga kaklase. Okay? Yun. And then, let's make it memorable, guys. This will be our last semester here in Sayay. So, gawin nating smooth, quality learning, tapos memorable. Okay, so that's all for the short orientation for General Physics 2. And obviously today, further ado, we're going to tackle the first topic. So kung napansin nyo po, dun sa Google Meeting natin, ang pag-aaralan po natin ngayon is electric charge. This is lesson 1.1. some of the information here ay recall na lang nung sa graded sciences nyo. For example, yung mga charges na nagre-repel, nag-a-attract. So, alam nyo yon. Di ba kapag unlike charges, nag-a-attract, kapag naman, what do you call this one, unlike charges, so magre-repel naman siya. Babalikan natin yung mga pinag-aralan natin sa atoms. Okay, so let us have first the set of competency today. So describe using a diagram charging by rubbing and charging by induction. Actually, hindi lang naman siya rubbing or induction. Marami tayong ibibigay na ways to charge rub or any kind of material. Then explain the role of electron. Para saan ba siya? And describe experiments, paano mapapakita yung mga charging by induction, by conduction, or by friction. And then calculate the net electric force on a point charge given yung formula natin ng Coulomb's law. So you're going to apply paano natin makukuha yung electric force. Kung meron kayo diyang calculator, please makikilabas na kasi gagamitin natin siya today. Okay? And then, let's learn something, guys. So, nag-prepare po ako dito ng video. Huwag niyo po sanang i-judge yung ano ko, ginawa ko. Ito nga pala ay inspired by Crash Course Physics. So, may proper citation and credits naman to. Actually, itong video na to, may share ko lang. Ito kasi yung pinasa ko dun sa OBS namin. Di ba nagkaroon kami ng inset yung seminar yung mga teacher? So, ni-require kaming maggawa ng video lecture. So, medyo ang hinhina, alam nyo kanina, ma-share ko lang. Kasi pinaano ko siya dun sa Rutherford. Pinagtawanan nila ako. Hindi ko na magtawanan, guys. Kasi ang hinhin ng boses ko dun. Pero napaka-fruitful nung video kasi ang daming malalaman dun. So, this is a 15-minute video. So, kung kaya nyo po mag-take down notes, after that video kasi, magkakaroon po tayo ng, yes, i-recall ko yung mga topics na diniscuss dun sa video na yon. Pero some, I believe na na-take down notes nyo na kasi at the end of this discussion, magkakaroon po tayo ng 15-item short quiz. Okay? Okay. So, wag sana po kayo ma-board at makinig po.
The shock you get from a doorknob, the trick you used to do with a balloon to make your hair stick up, or of course, a lightning strike. They're all governed by the same principle, static electricity. Static electricity occurs when an object obtains a net amount of positive or negative electric charge, creating an imbalance that wants to be returned to equilibrium. Its effects aren't always as dramatic as lightning though. Let's take two pieces of tape that are both stacked to a table. If you read them both of the table and try to stick them together, that should be easy enough, right? But it turns out that they repel one another. Try this. Stick one on top of the other. Rip the pair of the table and then separate the pieces. They're no longer repelled. Now they're attracted to one another. In the first scenario, both pieces of tape stole negative charges from the table. And since like charges repel, the pieces move away from one another. In the second scenario, one piece of tape stole negative charges from the other, leaving the pieces with opposite overall charges and making them attract. Our study of electricity begins here, with basics observation about electric charges that hundreds of years ago sparked the imagination and innovation that changes our world forever. Good day everyone. So today we're going to discuss about electric charges and Coulomb's law. Under this, we have the most essential learning competency. Number 1, describe using a diagram charging by rubbing and charging by induction. For number 2 is to explain the role of electron transfer and electrostatic charging by rubbing. And we also have here the specific objectives for today's lesson. Number 1, define and describe electrical forces. Number 2 is to enumerate the ways and how electrical charge can be altered and rearranged. 3, explain and apply Coulomb's law in a system of point charges. And lastly is to identify how the charge particles is calculated over vectors. Okay, so let's start. To understand electricity, you should start with an atom. Atoms contain charged particles, positive protons, and negative electrons. And generally, there's an equal number of each, meaning the net electric charge of the atom is zero. It's electrically neutral. In solid materials, protons stay fixed, but some electrons are free to move around. These moving electrons are called free electrons. They reside in an atom's outer shell as valence electrons and are easily plucked off and carried around when acted upon by an outside force. How easy it is for electrons to move around depends on the material, and we describe the materials in the same manner we do for heat transfer, with conductors and insulators. Materials that are conductors, like copper, let free electrons move freely throughout the solid, while insulators, like wood, hold onto them tightly, limiting their flow. So we've got insulators and conductors with free electrons moving around in them. But what causes these charged particles to move in the first place? The answer is an imbalance of electrical charge. When some part of an object has a different number of free electrons than another part. When we talk about an object having an overall negative charge, we mean that it has too many electrons. And when we talk about an object having an overall positive charge, we mean it's missing free electrons. This imbalance can be created and resolved in lots of different ways. Say you have a glass rod that's electrically neutral and you rub it with a cloth. That physical interaction causes electrons to hop onto the cloth, leaving the rod with an overall positive charge. This is called charging by friction. Both the cloth and rod begin with a neutral charge, but after friction, the rod has a net positive charge. But whether the rod ends up with a net positive or negative charge depends on the materials that you use. The ancient Greeks actually rubbed fur against amber and discovered that the amber would then attract hair and feathers. Today, we understand that the fur stole electrons during the process, giving the amber an overall positive charge, just like the glass rod. Now, it's important to know that no new charges were created during this process. The overall charge between the two objects is still zero. This is known as the law of conservation of electric charge. It says that you can never create a net electric charge. Instead, charge can only move from one place to another. Now, if we bring our positively charged glass rod in contact with another neutral rod, some of the negative charge, that is, some of electrons, will jump from the neutral rod to the positive one until both objects have the same distribution of charge. We have two rods that are both slightly positive. This is called charging by contact. When the two objects touch, charges move between them. Okay? So, charges can move when different materials touch each other, either through friction or simple contact. But materials don't actually have to touch in order for their electrons to get all rearranged. Say you bring a positively charged rod close to a metal conductive rod. Then, the electrons in part of the metal rod will be drawn towards the positive rod. Now, the side with more electrons has a negative charge, leaving the other side of the rod with fewer electrons and a positive charge. You know what we've done here? We've polarized the metal rod. We've redistributed the charge in order to create an imbalance of charge within an object that still electrically neutral. Now, imagine that we slice the metal rod right down the center. It still hasn't touched the positive rod, but since we split it while an imbalance was present, we're left with one positive side and one negative side. This process is known as charging by induction, creating a net charge without conducting another object. Now, if a charged object is connected to a much larger neutral conducting object, then the net charge gets redistributed so that the smaller object loses most of its net charge. But the question is, how large an object are we talking about exactly, right? Well, how about the Earth? The Earth's surface is a fairly good conductor. In most places and for our purposes, it can be considered neutral. So, connecting a charged object to the ground creates a way for the charge to leak in the earth, rendering the object electrically neutral. We call it grounding. So, let's say we repeat the previous experiment, but we bring a negatively charged rod close to our neutral one. The neutral rod becomes polarized with a net positive charge close to the charged rod and a negative charge on the opposite side. But if we ground the metal rod, the negative charges repelled by the charged rod now have a place to go. Where? The earth. The negative charges scurry away, leaving the metal rod with an overall positive charge. Now, if we serve the connection to the ground, our rod remains positively charged. This process required no contact between the rods, only a connection to the ground. Okay, so we've talked about how opposite charges attract and like charges repel. But how do we quantify those interactions in terms of equations and units? Well, we'll want to find the force on charged particles in newtons. But to calculate the number of newtons, we'll first need to measure the charge, denoted by Q, in units called coulomb. Since objects can be positively or negatively charged, Q can have both positive and negative values. For example, one electron has a charge of negative 1.6 times 10 to the negative 19th coulombs. That means there are 6.24 times 10 to the 18th electrons for every negative coulomb. This value, or the charge of a single electron in coulombs, is known as the elementary charge, and it's denoted with a lowercase e. We'll use this notation a lot when talking about protons and electrons, since protons have a charge of positive E and electrons of negative E. Now that we have a way to measure the charge, we can calculate the force between particles, right? And that equation we use is very similar to the one we use with gravitation. It's just that instead of using kilograms to find newtons, here we're using coulombs to find newtons. Our equation here states that the force between two charged particles is equal to the product of the two charges divided by the distance between them squared. And the distance is squared because, just like gravitation, when the distance between objects doubles, the force between them reduces to a quarter of the original value. Please take note of that. And also, as with gravitation, this force has its own proportionality constant. It's labeled lowercase k, and its value depends on the medium that surrounds the charges. The vast majority of the time, the medium you'll be working will just be the air or possibly a vacuum. And in both cases, the constant is 9 times 10 to the 9th column. So when you multiply the rest of the expression by k, that gives the result in terms of newtons. This whole expression is known as Coulomb's law, and K is often known as the Coulomb's law constant. Now, gravitation and electrostatic force work in totally different ways. Of course, we have to express them differently too. The force of gravity, after all, is always attractive. But the electrostatic forces can be either attractive or repulsive, depending on the signs of the charges. So the product of the two charges can be negative or positive, with the resulting sign of F being plus or minus, corresponding to either attraction or repulsion. Now let's put Coulomb's law to the test. Let's say there are two electrons that are 1 nanometer apart. That's 1 times 10 to the negative 9 meters. You can calculate the force between them by multiplying their charges, which are both negative 1.6 times 10 to the negative 19th coulombs, divided by the distance between them squared. You then multiply that by K, and the resulting force is positive 2.3 times 10 to the negative 10 newtons. Now, notice that the answer is positive. That means the electrons repel one another. If we use a proton and an electron the same distance apart, we get negative 2.3 times 10 to the negative 10 newtons, meaning they attract one another. And just like other forces, vector addition also applies here too. This means we can solve for the net force on a charge by using Coulomb's law or each pair of charges in any situation. This means we can solve for the net force on a charge by using Coulomb's law on each pair of the charges in situation. From Coulomb's law, we can calculate the magnitude of the force and find the direction based on the sign of the result. So,
Okay, so done tayo sa panonood ng video. So, some introduction on static electricity and electric charges. So, I hope meron kayong natutunan doon and nakapag-take down notes or kung hindi, at least maalala natin. So, recall natin siya ngayon. So, kung mapapansin nyo, meron tayong mga instances. Naririnig po ba ako na ayos? Oh, yan. Meron tayong mga instances na nagkakaroon tayo ng spark sa mga bagay-bagay. Ano? Ang pinaka-common dyan is yung sa doorknob. Ewan ko kung na-experience nyo to kapag ito ay malamig ang panahon. Kasi pag malamig ang panahon, yung doorknob daw ay nagiging positively charged. Ikaw naman is negatively charged. So pag bigla kang humawak doon, so nagkakaroon ng spark doon. So at least nagkaroon kayo ng spark doon sa pinto. And minsan, pwede din yung balloon and then yung ating hair, didikit yan kasi yan ay magkaiba yung charges niya. And then also lightning, bakit? Kasi merong negatively charged yung kidlat and then medyo malamig kasi yung panahon sa atmosphere kaya nagkakaroon tayo ng lightning strike. Okay, so recall natin ang sinabi kanina, when we say static electricity, nangyayari daw to kapag meron tayong object tapos nakakapag-obtain siya ng net amount na positive and negatively charged. Also, electrostatics is the interaction between electric charges that are at rest. So, tandaan na ang tawag natin po kapag yung mga electric charges is nakarest tapos magkakaroon ng interactions, we call it static electricity. From the word static, of course, is at rest. What else? We also tackle about charges. So, meron po tayo dito si comparing. Sino kaya to si comparing ito? Kilala niyo ba siya? Anyone? Sino nakakilala dito? Baka nakakasalubong niyo na pala to. Sorry. Anyone? Baka po. Sige. Okay, tama si Elisha. So, ito ay si Benjamin Franklin. Si Benjamin Franklin ang siya yung nag-prepared ng positive and negatively charged particles. So, siya isang American statement. And again, pangalan niya po is si Benjamin Franklin. So, para sa kanya, or yung isa sa mga pinipose niya, is that charges, yung mga like charges sa magkaparehas, obviously nagre-repel. Even though parehas yung positive o parehas negative, magre-repel at magre-repel yan. Kasi nga, hindi sila, masyado na silang pareha, so hindi sila mag-a-attract. Kapag unlike charges naman po, mag-a-attract po yan. Okay? Okay, now let's have atom. So this one is an example of a model of an atom. Familiar? So sino po kaya yung dalawang, yung apat na bilog dyan sa loob na yan? Anyone? Pabukasan pa po ako ng cam para sa iba, para nang makita ko kayo, guys. Sige na, sige na. Yes, Pablo.
Ma'am Phil, kung ito po yung nucleus ng atom, yung nasa gitna po ay protons po at saka po neutron.
Okay, very good. So obviously, nucleus po yung nasa loob, then nandun si protons at si neutrons, and then si electrons naman po. Nasaan nga ba si electrons dito? Patricia Colera? Sa tingin mo, nasan dyan si electrons?
Ma'am, nasa labas po nung ano.
Okay, so nasa labas siya ng nucleus, tapos nag-move siya dyan freely. Now, yung atoms po ay tinatawag yang, or kumbaga ang atoms ay nanggaling sa word na Greek word, tapos ang ibig sabihin niya is undivided. Bakit tinawag na undivided? Kasi siya na yung smallest part. Tama ba? Now, to understand electricity, kailangan kasi nating magsimula dun sa atom to know what are the charged particles na alam natin. Pag positive, proton, pag negative, electrons, at kung neutral naman, edi we have neutrons. And another sa dapat natin tandaan are the constant numbers. So we have electric charge and we have the mass of a different, for example, proton, neutrons, and then electrons. Kung mapapansin nyo, since neutral nga si neutrons, edi wala yung E. Si protons, meron yung E. Pero positive. Pareha silang 1.6 times 10 to the negative 19. Pero pag electrons, negative. Yung mga M po, mass yan ha. Importante na alam ang mass. Kailangan bang sauluhin to? Hindi naman kailangan sauluhin to, lalo na kung meron kayong calculator. Alam nyo ba kung paano mapalabas yung mga number na to sa calculator? Okay. Actually, dati kasi, no college kami, pinapasaulo sa amin tong constant na to. Medyo limot ko na nga to ngayon. Kung mapapansin nyo yung 7, yung number 7, di ba sa taas niyan merong cons? C-O-N-S? Ang tawag dyan, constant. So, dapat ito yung sauluhin nyo, hindi itong mismong number na to. Kasi kung itong mga number na 1.673, maluluko kayo pag sinaulo nyo to. Ito pag dumating ang panahon na kailangan yung mag-board exam, ganun. Kasi sa board exam, wala naman kasing, hindi naman open notes. Calculator lang ang tanging basihan natin doon. So, sa math, okay. Ilabas, saan kaya natin makukuha yung E? Yung E po ay constant 23. So, pindutin po yung shift, and then 7, tapos may lalabas dyan na number. Tapos tatanungin kayo. Ito po, sa ulado talaga dapat. Sa ulado ko to ng college, ngayon medyo limot ko na. So, pero yung E, number 23 yan. So, pag pinindot mo yung E, lalabas yun 1.6 times 10 to the negative 19. Makikita mo, mahaba yan. Yan yung mismong value niya. Paano naman yung mga mass? Yung mass naman po is, yung proton ay 1. Paano yung 1? E di enter mo yung shift constant uli, and then 0, 1, lalabas yung mass ng proton, which is 1.673 times 10 to the negative 27. Yung neutron po, number 2. So, ganun uli, constant 0, 2. Tapos lalabas yung Mn, 1.675. And then yung electrons ay number 3. Itong tatlong to, sa ulado ko to kasi madali lang. 1, 2, 3 lang naman yan sa calculator. Kaya, ayun, madali siyang malaman. And then yung E, ay madaling tandaan yung 1.6 times 10 to the negative 19. Pero kung sakaling dumating yung panahon na hindi mo talaga matandaan, sana maalala mo na pang number 23 siya sa constant. Okay? Okay, now, so we're done to the basic structure of atom. Let's move on to one part of an atom, which is the free electrons. Bakit kaya siya tinawag na free electrons? Anyone po? Bakit tinawag na free electron siya? Nabanggit na yan kanina. Yes, Nicole?
Ma'am, kasi po gumagalaw po sila free.
Kasi gumagalaw. Yes, gumagalaw. What else? Ano pa yung masasabi niyo tungkol sa free electrons? Yes, Angela. Angela, kamusta ka na? O, Angela.
Ma'am, kasi po sila po yung mabilis makuha tas maalis po.
Okay, so mabilis silang makuha at madalis umalis. Bakit kaya? Bakit saan ba nakapwesto tong free electrons na to? Bakit siya madaling umalis at makuha?
Ako po ulit, ma'am.
Sige, go lang, Angela. Kung alam mo yung sagot.
Kasi po, sabi po nung kanina kasi po sila yung nagre-reside sa, ano po, sa outer shell po nung atom bilang valence electrons.
Okay, very well said. So, free electrons resides in an atom's outside shell. So, kapag nasa labas yan, edi obviously mas madali siyang makuha, mag-block off, or ma-carried around. Lalo na kung meron ng outside force yan. Now, we have a process called ionization. Makikitandaan. Ionization is the gain or loss of electrons. Pag may nawawala, may dumadating, ionization po yung tawag natin doon. So we have two kinds of ions kapag nagkaroon tayo ng ionization. Pwedeng maging positive ions, pwedeng negative ions. Kailan nagkakaroon ng positive? E di kapag nawala ang isang electrons. Kasi ang electrons ay negatively charged. Kapag nawala yung negative mo, e di nagiging positive ions. Sa negative ions naman, kapag may dumating na electrons, which is negatively charged nga, nagiging negative yung ions. Okay po? Baka malito sa idea na, remove, bakit naging positive? Eh, ang usapan naman kasi natin is electrons, which is negative charge. Okay po? Okay, now punta tayo sa facts on atoms. We have 4. So, every atom is composed of positively charged nucleus around, which are electrons. Then, electrons of all atoms have the same quantity of negative charge and the same mass. Number 3, the nucleus is composed of protons and neutrons, katulad ng sinabi kanina. And since si protons yung nag-i-stay sa loob, kung bakit siya nag-i-stay sa loob, kasi siya yung mas mabigat kumpara kay electrons. Kaya si electrons madali din makuha kasi medyo magaan lang siya. But take note that they carry an amount of positively charged equal to the negatively charged. Neutrons are slightly more massive than protons and have no net charge. So kung tinanong kayo, sino yung may pinakamabigat dun sa tatlong yun? So ang pinakamabigat ay si neutron. And then number 4, all normal atoms have exactly as many electrons surrounding the nucleus as there are protons within the nucleus. Thus, a normal atom has no charge. Pag normal atom has no charge. Okay, so we are done to charges. Let's move on to law of conservation of charges. Baka may nakakatanda sa sinabi kanina. Or kung hindi, di ba pag sinabi naman nating law of conservation, kahit energy man yan, napag-aralan na natin yan sa energy, ano nga bang ibig sabihin pag law of conservation? Pero this time, charges ito. Anyone po? Law of conservation of charges. Parang law of conservation of energy lang to. Okay, so sumagot si Ronald, charges cannot be created nor destroyed. So, tama po yun. Electrons are never created or destroyed but are simply transferred from one material to another. Makikitandaan po ang law of conservation of charges. Okay, now, paano po natin may apply ang law of conservation of charges? By means of different ways of charging. Kanina may nabanggit tayong 4. Una is charging by friction, followed by charging by contact. Meron din tayong charging by induction, and then merong grounding. So, 4 po yung nabanggit kanina. Tignan natin yung iba nung 4 na yon. Yung una, charging by friction. As you can see, ang goal naman yan, as you can see, magra-rub. So, kapag merong rubbing ng mga materials, edi yung mga positively charged, magiging matatransfer yung electrons natin from cloth to the rod. Again, so you have a glass rod that's electrically neutral and you rub it with a cloth that physical interaction causes electrons to hop onto the cloth. And then we call it charging by friction kung magkakaroon ka ng rubbing. Diyan din nangyayari yung ano, 'di ba? Tandang-tanda ko grade 6 ata, yun yung pinagdala kami ng suklay, tapos irarab mo siya sa isang silk cloth, tapos may mga pira-pirasong papel, tapos pagkatapos mong mairab yung suklay, ilalapit mo naman ngayon yung suklay dun sa mga pieces of paper. Tapos nadikit yung pieces of paper dun sa rub, kasi nga nag-transfer na yung electrons niya. So, again, charging by friction is by means of rub. How about charging by contact? So obviously, may dalawa kang rod dyan, and then pag lalapitin mo, we call it charging by contact. And also, hindi lang po nailagay dito, makikitandaan, tinatawag po natin siyang conduction. Diba? Para lang naman yung the transfer of heat, conduction. Pag conduction, pinaglalapit mo. So therefore, we can conclude that conduction and induction is a very different thing. Pag conduction, may contact. Kapag induction, ay wala. So, ang conduction po, induction pala is even without the contact, magta-transfer yan. Tapos yung tinatawag naman nating polarization, sinabi lang dito na yung polarization na kahit hindi sila dikit, lalapit si electrons dun sa positive. Ano po? So, the materials don't actually have to touch in order for their electrons to get all rearranged. So, ang mahalaga doon is, pero syempre, wag naman yung sobrang layo. About, limbawa, mga nanometer, ayun, malaki yung chances sa talagang maglilipat yung electrons natin. Then we have charging by induction. Again, contrast ng conduction, even without the contact. Pero here, bakit kaya may pinakita ditong paghahati? Bakit kaya may hinati dito na rod? Anong gusto niyang ipakita? Other hand. Okay, yes, Pablo.
Ma'am, kaya po ipinakita po na kahit po hatiin yung sa isang rod, kasi di ba yung sa induction po, wala pong contact. So, yung negative charge po dun po sa right na rod ay na-concentrate na po dun po sa left side kasi po attracted po siya dun sa positive side. So, kapag po nangyari po yan, parang may shift po ng electron. So, may shift po ng charges. So, yung electrons po ay concentrate po dun sa left at saka yung positive po na natitira ay dun naman po sa right. So, kahit tanggalin niyo po yun, concentrated na po yung electron dun po sa left kasi nga po mas malapit po siya sa positive charge din sa isang rod.
Yes, thank you. So, ibig sabihin, kung manahati mo na yung dalawang rod, yung isa magiging positively charged, yung isa negatively charged. Ang tawag po natin dyan is the imbalance split. Kasi hinahati po natin sa gitna. Tapos, meron pang induction, edi parang kung gusto mong hatiin or paghiwalayin yung charges, edi gawin mo yung induction and then split mo yung rod. And then lastly, we have grounding. May mga grounding tayo sa bahay. Ito ay depende sa bahay. Kalimitan ang may grounding is halimbawa yung mga proper installation, halimbawa ang nagtayo talaga ng bahay is or may plan ng electrical engineer, may grounding yan. Para saan po kaya ang grounding? Anyone? Bakit kailangan may grounding? Alam niyo ba yung grounding? Halimbawa, may circuit breaker. Yung circuit breaker nakakonekta sa isang tubo na yung tubo ay nakatanim sa isang backyard, tapos syempre may tubo doon. Kalimitan dyan yung copper, tapos naka-ground. Grounding yung tawag. Bakit po kaya may grounding? Any idea? Yes, Eric.
Para pigilan po yung electricity surge po sa mga appliances sa bahay.
Okay, very good. So, ang grounding po ay halimbawa magkakaroon ng overloading kasi sobrang dami na ng appliances mo. Hindi masisira yung appliances mo. Kasi yung excess electrons or electricity hindi pupunta dun sa equipment. Saan ang punta niya? Dun siya pupunta sa earth. Kasi ang overloading nagkakaroon ng labis na bilang ng electrons. Especially kung halimbawa ikaw mismo yung nakahawak dun sa faulty wire. Kung may grounding, hindi ikaw yung makokuryente. Hindi ikaw agad ang makokuryente. Ang punta agad ng electrons ay sa ground, which is napaka-safe talaga. Kaya kalimitan sa mga company, pabrika, talagang merong proper grounding. Ano po? And kung mapapansin nyo po, kalimitan sa mga heavy duty na equipment, for example, washing machine, microwaves, laptops, di ba meron siyang tatlong prong? Ang tawag natin doon prong or outlet. Sige, outlet siguro yung pagkaka-imagine nyo. Di ba yung saksakan merong tatlo? Halimbawa ito yung dalawa. Tapos meron pang patatlo dito. Kung na-imagine nyo. May mga saksakan na tatluhan. Yung patatlo ang tawag natin doon ground. Yun yung ground. Kalimitan sa mga heavy duty equipment yon para hindi siya agad yung masisira in case na nagkaroon ng short circuit or overflowing ng ating current. Okay? Pero kalimitan, 'di ba, kapag ang saksakan natin dalawahan, naglalagay tayo ng adapter yung box para dalawa lang yung magiging output. Pero kung papansinin niyo yung adapter, meron pa rin yung plate. Meron yang nakabalikong parang aluminum, pero hindi yun aluminum. Ayun yung nagsisilbing grounding. Kasi mahalaga na may grounding yung mga devices na kailangan talaga. Kung hindi, ay masisira yun. Okay? So, yun yung use ng grounding. Sa dito naman, mapapansin natin na sabi nga natin, si Earth ay good conductor, tapos ina-absorb niya talaga yung mga electrons once na nilagyan siya. Okay, so we are done to law of conservation. Punta tayo sa electric forces or what we call as Coulomb's law. This will be, ito naman si Charles Augustin de Coulomb. Siya yung nag-propose na formula under Coulomb's law. So makikitandaan po nito. Ito yung formula ni Coulomb. So makikita na magnitude of electric force between 2-point charges is directly proportional to the product of charges and inversely proportional to the square of distance between them. Bakit R na ginamit dito? Sa tingin niyo bakit R? Sa tingin niyo? Bakit kaya R siya? Sa tingin niyo may kinalaman siya sa radius? Ba't kaya hindi na lang distance na D? Yes, Fiona.
Ma'am, feeling ko lang po may kinalaman po sa radius kasi po 'di ba po yung ano po na electrons ay pabilog.
Okay po.
Ayun lang po.
Okay, so
Tas
tama
'di
na.
ba 'di ba po yung distance po nung dun magkabila po ay radius po at yung tawag. Yun lang.
Okay, tama naman po yan. Yes, tama. Kasi talaga may kinalaman. Kasi kalimitan naman talaga, ang flow ng electrons ay pabilog siya. And kung maaalala nyo, may sinabi kasi kanina, yung, di ba, ano ba to? Wait lang. Yung Coulomb's law, para lang din daw siyang sa gravitational. Di ba may nabanggit kanina doon sa video? Kasi nga, yung, kung i-imagine mo na itong Q1 ay yung sun, tapos yung Q2 yung earth. So, di ba, radius naman kasi yung pagitan nila. Lalo na if we are talking about the solar system. Tapos, same lang din yung formula niya. Tandaan nyo na itong Q1, Q2, katulad ng gravitational force formula. Okay? So, going back, yan. Recall lang tayo. Where K is a proportionally constant whose numerical value depends on the system of units. So, ano nga yung formula ng K? Or kung ano yung constant, anyone? May nakakatanda ba? May nakakatanda po nung yung constant natin. Yes, Asher.
Ma'am, try lang po ha. 9
Yeah.
times 10 to the power of 9 Newton meter squared over Coulomb squared.
9 point ulit.
Ano po ma'am? 9 times 10 raised to the power of 9 Newton meter squared over Coulomb squared po.
Hindi yun. Yung K lang ha, K lang ha.
Okay po.
Anyone, sino yung nakakatanda nung K? Actually, yung K, wala yan sa calculator. Yung Coulomb's law constant, wala. Okay, so ang K po ay makukuha mo, kung hindi mo alam yung constant, edi makukuha mo naman siya by means of 1 over 4 pi EO. Yang EO, yan yung meron sa calcu. Yang EO po ay number 32 sa constant. So kung halimbawa nilagay ko po siya sa calcu, yan po, kita nyo po, yung 1 over 4 pi EO, number 32 po yung constant. Ang ginagawa ko lang dyan, diretso yung formula, tapos pindutin mo lang, pag nadun ka na sa baba, itatype mo na yung EO, edi shift constant 32, lalabas to. So therefore, we can conclude that K is 8. Sabi mo, Asher, 9 point, ka ba? 9 yung
Opo
exponent na
ma'am,
sinabi
9
mo.
lang po yun 9 times 10 to the power of 9 po, ma'am, ang
Ayan,
nasabi
tama
ko
ka
po.
pala. I'm sorry. Ayan, tama ka pala. Very good. Yan. Pero kung hindi niyo po matandaan, edi ito po, lalo na kung ang hinihingi ay exact value ng K, edi use your calculator. Okay, so we are done. Let's review the concept we've learned today. So we tackle the basic of atoms, fun facts, and different, what are the charges, and then charging. Again, meron tayong 4 na charging. Free electrons, bakit siya tinawag na free electrons? Because siya ay nag-move freely. Coulomb's law, makikitandaan ng formula, and then the law of conservation of charges. Okay, so any question, Huygens? Meron pong tanong? Wala na pong tanong? Yes, Pablo.
Ma'am, yung pong sa kunyari po, yung sinabi niyo pong cloth at saka purad, paano po, prerequisite na po bang alam na, for example, yung cloth po ay negative charge, ganun?
Oo, lagi. Yung cloth
Paano,
ay ano yan?
lagi po siyang ano,
Oo,
lagi
lagi
po
siyang
siyang negative
negative.
din po mga
Yes,
ganun.
negative. Oo, lagi siya. Di ba't laging siya yung na-attract lagi? Lalo na yung binigay na example kanina ni Amber at ni Four, ay yung balahibo. Laging siya yung negative, kaya siya yung laging na-attract. Meron pala akong idadagdag, may nalimutan pala ako dito. In terms of atoms, halimbawa meron akong 3 electrons, pero meron akong 4 na protons. Anong tawag natin sa kanya? Electrically o, negatively charged or positively charged? Meron akong 3 electrons, 4 na protons. Anong tawag natin sa kanya? Negatively charged or positively charged? Okay, so obviously ang tawag po natin doon is positively charged. Nagmamatter kung sino yung mas malaki. Laging titignan kung sino yung mas malaki yung bilang, si protons ba or si electrons or baka si neutron. Kung sino yung mas malaki yung bilang, edi yun yung tawag natin sa charge nila. Okay, kung wala na pong tanong, okay, so kindly, may tanong si, yes, Carl, JC.
Ma'am, pwede pong paulit po nung dun sa ano po. Paano po yung gagawin dun sa EO?
Sa EO
K
po.
Sa cycle po.
Ayun, yung K kasi, yung mismong K, walang ganyan sa calculator. Ang meron tayo yung EO. So, ang gagawin ko, itatype ko lang yung 1. As in, i-fraction mo, 1 over 4 pi. So, type mo yung 4 pi. Tapos, kung gusto mo na diretso na agad yung EO, di ba yan, may ganyan ka na.
Okay.
Mag-shift 7 ka na, tapos enter mo yung 32. Yung 32 kasi yung EO. Kasi
Okay.
dapat ganito
Thank you
yung
po,
itsura
ma'am.
niya.
Thank you po, ma'am.
Okay, yan. Nakita mo ba, Asher? Nakita nyo ba to? Malinaw ba siya? Mukhang malinaw naman, tingin ko. Nakikita niyo? Visible ba siya? Pag pinapakita ko to, wala din palang sense, ano. Okay. Okay, kung wala na pong tanong, kindly prepare any kind of paper dyan. 1 to 15 po. Ready na po? Makikibukas po ako ng camera. Kung hindi naman ikakabagal. Okay, number 1 po. Ay, so, ano pala, ano to? Makikisulat po ng buong word. Electric energy is produced by the movement of Planck. Erasure means wrong. Pero okay lang kung mali yung spelling, ganito, ganyan. Basta yung totally nabura. Electric energy is produced by the movement of, pasabi na lang po kung medyo mabilis ako. Number 2, material through which electrons or electric charge do not flow easily. Do not flow easily. Okay, number 3. The girl's hair and the comb have the girl's hair and the comb have number 4. What is the unit used to describe electric charge? Parang okay, number 5. If an element has 6 protons, 7 neutrons, and 6 electrons, what type of charge does the element have? Okay, number 6. If a substance has a higher number of electrons than protons on its surface, what type of charge does it have? Number 7, the gain or loss of electrons. The gain or loss of electrons. Okay, number 8. When you charge an electroscope by touching it with a charged balloon, the process is called. Okay, Dan, pasabi na lang po kung medyo mabilis ha. Sabihin nyo kung kailangang magpreno. Okay, ilan ba to? Number 9 na ba tayo? Tama na. Okay, number 9. A circuit that is connected to Earth is said to be. Okay, number 10. Electrostatic force is directly proportional to. Okay, number. Ano na to? 11? Do the spheres attract or repel after they exchange charge? So, ang titignan nyo lang naman dyan yung after. Okay, number 12. Letters only po. Protons do not jump from object to object. Electrons, however, are able to jump from object to object because they are yung best ha, yung best po ang ilalagay nyo dyan. Okay, let's have tatlo na yung sagot dito. 13, 14, 15 na po ito. Letters only. Choose 3 correct statements. Okay, so thank you so much, Hygen. So ako na po ang mag-check niyan. Makikisend na lang po sa akin messenger. So iwan ko lang po ang quotation by Nikola Tesla. The day when we shall know exactly what electricity is will chronicle an event probably greater, more important than any other recorded in the history of the human race. Okay, any questions po? Kindly PM me or kung meron nang gusto kayong concerns and issues, directly message me na lang. Okay? So thank you so much guys. Hi again. So pwede na po kayong kumain. Have a nice day everyone.
Thank you
Bye!
po.